Right, in this lesson, we're going to cover the law of cosines. And if you watched the previous video on the law of sines, we went through the 4 cases of how to solve for triangles. And the first 2 involved using the law of sines. So now the next cases 3 and 4, if you're given side, angle, side, so 2 sides and the angle between them, or side, 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 all 3 sides of a triangle, you're going to use the law of cosines to solve. So the law of cosines is as follows. For a triangle with sides A, B, and C, lowercase, and opposite angles A, B, and C, capital, respectively, we have that C squared equals A squared plus B squared minus 2AB cosine C. And then the pattern follows. Notice whatever side, this is the side because it's lowercase, is squared, you have cosine of the angle opposite that side on the other side of the equation. So B squared, this one has cosine B. A squared, this one has cosine A. And then it's always the sum of the other 2 sides squared minus 2 times their product with cosine of the angle that is opposite the side that's isolated on the left-hand side of the equation. Okay? And something I wanted you guys to notice, if you have a right triangle, and typically we label our right triangles with the 90 degree, the right angle, we call it C, right? And this side is C. And then this would be, let's say, angle A, angle B, side A, side B. If I set it up so that I had C squared equals A squared plus B squared minus 2AB cosine of C, well, what's cosine of 90 degrees? Cosine of 90 is 0. So this whole term would go to 0 in a right triangle, and you're just left with C squared equals A squared plus B squared. And that's our Pythagorean theorem. So that means the Pythagorean theorem is just a special case of the law of cosines being applied to a right triangle. So the law of cosines works for any triangle, not just right triangles. But when you apply it to a right triangle, then you get a more simpler form, which is the Pythagorean theorem that we're familiar with. Okay, so let's look at some examples how to solve triangles using the law of cosines. So we have A is 2, C is 1, B is 10 degrees. So let's draw up a picture here so we can just orient things. It doesn't have to be to scale. So I'll label this A, B, C. So they told me angle B is 10 degrees, side A is 2, and side C is 1. So the first thing I'm going to do is solve for side B using the law of cosines. So that means B squared equals A squared plus C squared minus 2AC cosine B. And so A squared, that's going to be 2 squared, so that's 4. Plus C squared, that's going to be 1 squared, which is 1, minus 2 times 1 times cosine of 10 degrees. Okay, now from here, the rest you're going to do in your calculator. So type all of this in, and then remember to take the square root, because this is what B squared equals. And for now, we're just going to round everything to 2 decimal places. And we get B equals 1.03. Okay, so side B, let's go ahead and label that in the triangle now. I know that that is 1.03. Okay, now I need to find the remaining angles here. So I need to find angle A and angle C. Now, when doing this, you want to be strategic. You want to find the smaller angle first if you're going to use the law of sines. Because remember, the law of sines, when you put inverse sine in your calculator, it's only going to give you values between negative 90 and 90. So it's always going to give you an acute angle. And if you have an obtuse angle in your triangle, it's not going to give you the correct value. So what I'm going to do is I'm going to find angle C first, because I know that one has to be acute. How do I know that? Well, angle C is opposite side C, which has length 1, and angle A is opposite side A, which has length 2. And remember, since C is opposite a smaller side, it's going to be a smaller angle than A, so there's no way it could be obtuse. Remember, if you're going to have an obtuse angle in a triangle, you can only have one, since all the angles have to sum up to 180. So you can't have more than one obtuse angle. Not possible. So just always find the angle that's opposite the smaller side first, if you're going to use the law of sines. Okay, if that was a lot to digest, just give it some time. So we're going to use the law of sines now. So I know sine of C over 1 is equal to, and then now I'm going to have sine of 10 degrees over 1.03. Do you see how that works? Good. And then here we have sine of C equals, now it's just sine of 10 degrees over 1.03. So then you type sine inverse in the calculator. So C equals sine inverse of sine of 10 degrees divided by 1.03. And you should get 9.73 degrees. All right, good. And then all that's left, now that I know this is 9.73 degrees, is to figure out angle A. And to get A, I just do 180 minus 10 degrees minus 9.73 degrees. And A comes out to 160.27 degrees. All right, and then you don't ever want to leave your answer like that all crazy around your paper. So box everything nicely. So B is 1.03, angle C is 9.73 degrees, and angle A is 160.27 degrees. All right, looks good. Let's move on to our next example here. So we have side A is 6, side B is 4, and side C is 60. Okay, so they gave me angle C, that's 60 degrees. Here's angle A, angle B. Side A is 6 and side B is 4. So first thing I'm going to do is find side C. So side C squared equals A squared plus B squared minus 2AB cosine C. So that's going to be 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of 60. So that means C squared equals 16 plus 36 minus 2 times 4 is 8. 8 times 6 is 48. And we know cosine of 60 is a half. So 16 plus 36, that's going to be 52 minus 24, right? 48 times a half. So this is going to give me 28. So C is square root of 28, which is about 5.29. Good. I'm always extra proud of myself when I don't need my calculator. It's good exercise for your brain, which is a muscle. So try whenever possible to just use your mental calculator, okay, instead of the physical one. All right, so I have side C. Side C is 5.29. Let's go ahead and label that here. 5.29. And then now I'm going to go find the angles that are missing, okay? So there's angle B and there's angle A. Now, which one should I find first? Which one's going to be smaller? Angle B is opposite side B, which has length 4. Angle A is opposite side A, which has length 6. So we're going to find angle B first. So sine of B over 4 is equal to, now I'm going to use what I just found, so sine of 60 over 5.29 or rad 28, just if you want to be more precise in your calculator. So that means sine of B equals 4 sine 60 over rad 28, and then you take sine inverse of that quantity and you should get that B equals 40.89 degrees. All right, so all the hard work's done. Now to find angle A, you just do 180 minus the other two angles, so minus 60, which was given, and 40.89, which we just found, and that comes out to 79.11 degrees. So let's list everything we found nicely. So C, side C was 5.29. Angle B was 40.89 degrees. And angle A was 79.11 degrees. All right. Looks good. Now, a couple other cases here. So, for this triangle, notice they've given me, this is the last case, side, 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 all four sides, and I have no angles, okay? So, I'm going to use the law of cosines again to start. And when you're setting it up, you always want to find the largest angle first. Using the law of cosines. Because, remember, cosine inverse, that's going to give us values between 0 and 180. Ooh, sorry, cosines, I mean. That's going to give us angles between 0 and 180. So if we find the largest angle first, if it's obtuse, meaning if it's larger than 90, then cosine inverse will give us its correct value. And then I don't have to worry when I find the other angles. That's going to be my only obtuse angle, so I can use law of sines. And if it's not obtuse, then I know the rest are going to be acute as well, since it's the largest one. Okay, so let's draw out our triangle. Okay, so here's side A is 4, side C is 3, and side B is 5. You guys, I drew this as a right triangle on purpose. Don't you remember our 3, 4, 5 right triangle? So actually, I already know what B is, don't I? It has to be 90 degrees, but let's make sure. Let's use a law of cosines. So I'm going to have we're going to find B. So I have to have B squared equals A squared plus C squared minus 2AC cosine of B. So B squared, that's going to be 5 squared equals 4 squared plus 3 squared minus 2 times 4 times 3 times cosine of B, whatever that may be. So we have 25 equals 9 plus 16 minus 8 times 3, that's 24 cosine of B. So I have 25 equals 25 minus 24 cosine of B. So 0 equals negative 24 cosine of B, which means cosine of B is 0, and 1 is cosine 0 at 90 degrees, or pi over 2. Okay, good. So we've confirmed that that was indeed our right angle. Well, in that case, I can just use xoxo, right? Since I have a right triangle, meaning if I need angle A, I can just say sine of A is going to be ratio of opposite side over the hypotenuse, 4 over 5. So A is going to equal sine inverse of 4/5, which is about 53.13 degrees. Good. And then last one, I need angle C. So angle C is going to be, well, I already know B is 90, so A plus C must be another 90. So 90 minus 53.13, which is 36.87 degrees. All right, so we can list all our final answers now. So I know angle A is 53.13 degrees. Angle B was 90 degrees. And angle C was 36.87 degrees. Good. All right, well, they're not always going to come out to be right triangles that way. So let's look at one more example. Here we have the sides A, B, and C are 4, 3, and 6 respectively. So I'm just going to draw some arbitrary triangle here. I won't make it look like a right triangle. Okay, so here's A, here's B, here's C. So A is 4, B was 3, and C is 6. Okay, remember, you want to find the largest angle first. Which one's the largest angle? It's the one that's opposite the largest side. So I'm going to find side C, angle C first. Okay, so I'm going to set it up so that I have C squared equals A squared plus B squared minus 2AB cosine of C. So c squared is going to be 6 squared, which equals 4 squared plus 3 squared minus 2 times 4 times 3 times cosine of c. So this is going to be 36 on the left-hand side equals 16 plus 9 minus 8 times 3, that's 24 cosine of c. 16 plus 9, that's 25. So 36 equals 25 minus 24 cosine of c. Let's subtract that 25 over. And we have 11 equals negative 24 cosine of c. So cosine of c is equal to negative 11 over 24. And already I know c is going to be an obtuse angle. It's going to be larger than 90 degrees since cosine of c is negative, and cosine's negative only on its inverse in quadrant 2. So c equals cosine inverse negative 11 over 24, and we get approximately 117.28 degrees. Okay, so let's go fill that in our triangle. This is 117.28 degrees. Obviously, I didn't draw it to scale, but it doesn't matter here. So that's going to be my one and only obtuse angle, which means it doesn't really matter if I find angle A or angle B next, but I just always go for the whatever I feel like. So let's do A. So sine of A over 4 is going to equal sine of 117.28 over 6. So sine of A is going to equal 4 times sine of 117.28 degrees divided by 6. So A equals sine inverse of 4 sine 117.28 degrees over 6. And then if you put that in your calculator, you should get approximately 36.34 degrees. Okay, and then all that's left now is to find angle B. And angle B is going to be 180 minus angle C minus angle A. And you get about 26.38 degrees. Okay, so then let's list our final answer. Everything all together. So A, let's do a different color. Let's do this blue. A is 36.34 degrees. B is 26.38 degrees. And C is 117.28 degrees. Okay, good. So now you've seen how to solve all 4 cases. Case 1 and 2 from the previous lesson using law of sines, and then case 3 and 4 with the law of cosines. Now, how about an application? All right. An airplane flies 165 miles from point A in the direction of 130 degrees. Notice they're not giving us direction like using north, south, east, or west, or bearing or anything like that. So I'm just going to measure this the way we measure in standard direction from the positive x-axis counterclockwise. And then it travels in that direction 245 degrees for 80 miles. Approximately how far is the airplane from A? Okay, so the starting point is point A. What I'm going to do is draw myself my coordinate axes, and I'm going to put A at the origin, okay, since that's the starting point. Here's A. And it says that the airplane flies 165 miles from there in the direction of 130 degrees. So 130 degrees, that would be 90 plus another 40, and it flies 165 miles. So this is 90, and this little angle in here is 40, and this side here is 165. And then, for some reason, from there, it travels in the direction of 245 degrees for 80 miles. So from there, I'm going to put another coordinate system. So 245 degrees, well, let's see here. From here to here is 180, right? So then that means it's going to go another, let's zoom in, 245 minus 180 is 65 degrees. So it's going to travel in this direction for 80 miles, and this angle here is 65 degrees. Okay? And then the last part of the problem says, approximately how far is the airplane from A? So what they want to know is, here's the airplane now, how far is it from A? What's this distance? Let's call it X. Okay, I'm going to draw this triangle again without the coordinate axes so we can focus on labeling it better. So I have this side here, that's 80. I have this side here, that's 165. And then I need to figure out what X is. Okay, I'm going to put the 80 outside actually so you don't think it's an angle. Okay, well, what angles do I have? Well, we have to go back to our original picture so that we can figure that out. Now notice here, because I need this angle in order to use the law of cosine, so that's what I'm going to try to figure out. So notice, go back to the picture here. If this angle is 65 degrees, then I know this little piece in here has to be 90 minus 65. So that little piece must be 25 degrees. Let's get rid of that. So this is 25 degrees. Okay. And then I also know the measure of this angle here. Well, how do I know it? Well, notice, if this angle here is 40, then these are alternate interior angles. Maybe you haven't seen that for a while since geometry, but remember, when you have two parallel lines and they're cut by a transversal, your alternate interior angles are congruent. Okay, so this angle is 40 degrees and this is also 40 degrees. Okay, so that means that angle in the triangle here is going to be 65 degrees. Okay? All right, the worst part's over. The triangle is labeled. Now what I'm going to do is go ahead and solve for x using the law of cosines. So we're going to have x squared equals 80 squared plus 165 squared minus 2 times 80 times 165 times cosine of 65 degrees. Okay, and then from here, the rest just punch it in your calculator and then take the square root and you should get x equals 149.89 miles. All right, so anytime you do these problems with bearing, make sure you draw out your coordinate system, measure things very carefully, and figure out angles using some geometry techniques.